Welcome, this is Algebra 1B Part 1, Unit 5, Lesson 10. We're going to discuss a process called completing the square. Basically what this means is following a pattern that we pick up from squaring a binomial. And so I'm going to start this video off by looking at the pattern. We'll square a few binomials and then see what the pattern is, and then we'll use the pattern to solve quadratic equations. So, without further ado, x plus 1 quantity squared means x plus 1 times x plus 1. You may recall that in order to multiply the binomial out, we distribute the x to the x and the 1, and then we distribute the 1 to the x and to the 1. That is sometimes called FOIL, first outside, inside, last, or just distributing. When I do so, I get x times x is x squared. X times 1 is 1x. X times 1, or 1 times x, is 1x. And 1 times 1 is 1. Then you may recognize that we have two like terms in the middle, 1x and 1x together, making 2x's. So this results in x squared plus 2x plus 1. Okay, let's do it again for x plus 2. X plus 2 times x plus 2 is the meaning of x plus 2 squared. Distribute x times x and x times 2. 2 times x and 2 times 2. First outside, inside, last, FOIL. X times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. And when we add the two middle terms, we have 2x's plus 2x's equaling 4x's. X squared plus 4x plus 4. I'm going to do one more like this, and we'll see if we can figure out what the pattern is. So x plus 3 quantity squared means x plus 3 times x plus 3. Multiply it out. X times x, x times 3, 3 times x, 3 times 3. We get x times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. Combine the two middle terms. 3x plus 3x is 6x. 6x. So we get x squared plus 6x plus 9. Okay, now for pattern recognition. Notice when we did x plus 1 squared, we ended up adding 1x and 1x to make 2x. When we did x plus 2, we ended up adding 2 plus 2 to make 4x. When we did x plus 3 squared, we added 3 plus 3 to get 6x. So 2 was 1 plus 1. 4 was 2 plus 2. 6 was 3 plus 3. Likewise, the last term, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So notice the middle term is 1 plus 1. It's the 1 added to itself. And the last term is the 1 times itself. The middle term is the 2 added to itself. And the last term is the 2 multiplied by itself. The middle term is the 3 added to itself. And the last term is the 3 multiplied by itself. So let's jump straight to the end. For x plus 4 squared, it's going to be x squared plus 4 added to itself. 4 plus 4 is 8x. And then 4 times itself, 4 times 4 is 16. I got that from 4 plus 4 is 8, and 4 times 4 is 16. I took my 4 from there. That's the pattern. Okay, so we can jump straight to the end. And what's more is we can work it backwards here a little bit, and I'll show you in the next example. But let's do it one more time. X squared plus 5 plus 5 is 10x. Plus 5 times 5 is 25. Again, I get that from 5 plus 5 to make the 10x, and 5 times 5 to make the 25. So that's the pattern for completing for a perfect square. Now let's use that to solve a problem. And here's the problem I'm going to solve. I'm going to solve x squared plus 8x plus 12 equals 0. And it's a method called completing the square. You may recall we can solve this by factoring, right? Look for factors of 12 that add to 8. And you may recognize that 2 and 6, 2 times 6 makes 12, and 2 plus 6 makes 8. We're going to use the completing the square method. So the completing the square method is this. I'm going to start by subtracting 12 from both sides. What that does is leaves just x's on the left side of the equation. So we end up with x squared plus 8x and then equals negative 12. And notice I'm leaving a little bit of space. Now here's the trick. Just like in the completing the square problem, I want to think what plus itself makes 8. The answer is 4. 4 plus 4 makes 8. So over here I'm going to add 4 times 4, just like in my perfect square pattern. 4 times 4 is 16, so I'm going to add 16 to both sides of the equation. 16 is 4 times 4, and I got 16 from multiplying 4 by 4. I got 4 from realizing that 4 plus itself is 8. This is completing the square. And now the left side of the equation is a perfect square, and we can go backwards. We can write this as x plus 4 quantity squared. And on the right side, negative 12 plus 16 is 4. All right? So that's the trick. We'll try another example here real quick. And so now we can solve by undoing like we've done before. The opposite of squaring is square rooting. And when I square root both sides, I get a plus or minus root. I won't go into explaining why again. We've done that before. So we end up with x plus 4 equals negative 2 or positive 2. Then we can subtract 4 from both sides. Subtracting 4 from both answers. And we get x equals negative 6 or negative 2. Now the lesson uses the word and. It can't equal both at the same time, so or is a better choice. It equals negative 6 or negative 2. Okay, let's try one more example here. But this one will not work out quite so nicely because this is one that, got to get to the right one. There we go. This is one that doesn't factor. You can try to come up with factors of 12 whose difference is 6. They are 1 and 12, 2 and 6, and 3 and 4. None of them have a difference of 6. 12 minus 1 is 11, 6 minus 2 is 4, 4 minus 3 is 1. So this will not factor, but it is still possible to solve it. Still possible to find the roots or the zeros. And we're going to use the completing the square technique. I'm going to move the negative 12 to the opposite side by doing the opposite of minus 12 plus 12 to both sides. And I'm going to move that to the opposite side. So x squared minus 6x equals 12. Okay? And that's to clear the space to complete the square. Now think, what added to itself makes negative 6? What added to itself makes negative 6? Another way to say that is what is half of negative 6? And that is negative 3, because negative 3 plus negative 3 makes negative 6. So to figure out what to add to both sides, I'm going to add negative 3 times negative 3. Negative times negative is positive. 3 times 3 is 9. That's what I'm going to add to both sides. That completes the square. X squared minus 6x plus 9 is a perfect square. Now, so it can be written as x minus 3 squared equals, and 12 plus 9 is 21. Now take the square root of both sides. Square root, and when we square root, it's plus or minus. Plus or minus. And so we say x minus 3 equals positive or negative plus or minus root 21. Now it's okay to leave it like this, or you could write it as negative 21 root 21 plus or positive root 21 as two separate solutions. But now I'm going to get rid of the minus 3 by adding 3 to both sides. Okay, 3 doesn't have a square root, doesn't have a radical, so if I want to leave my answer exact, I need to write it this way. X equals 3 plus or minus square root 21. Now, if I want to get an approximate answer out of my calculator, I can bring up Desmos. And remember that SQRT is square root 3 minus SQRT 21. I'm going to go down 1 and hit 3 plus SQRT 21, and there's my two answers. Negative 1.58 to the nearest hundredths, or 7.58. 7.58. Okay? And so if we were asked to leave the answer in exact form, I would leave it like this. If we were asked to approximate the answer, I would leave it like this. Okay. Now there is one more kind of problem here. Sometimes we have a leading number on the first term. That doesn't make it impossible to complete the square, but in that case, I find it easiest to go to something called the quadratic formula. Now, the time does not allow me to derive the quadratic formula. The lesson does do that, and I could do that in a separate video perhaps. But just know that the quadratic formula comes from completing the square. It's just that all the work has been done for you, so to speak. You may think that is not the case because there's still quite a bit of work to do. But here's the quadratic formula, and this is to be memorized. You can put it in your notes, but write it down like 10 times and say it and walk as you say it. Get it in your memory. There's kind of a rhythm to it. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Negative b plus or minus square root b squared minus 4ac all over 2a. Repeat that about a dozen times until you can say it without looking, so that you can write it without looking. Here's what it means. A is the coefficient on x squared. B is the coefficient on x. C is the constant. And the quadratic formula is just to be plugged in. You can plug in those numbers into the quadratic formula. X equals negative b, that's negative 3, plus or minus square root b squared, that's 3 squared, minus 4 times a times 4 times c, negative 9. Be really careful about signs. If one of the coefficients is negative, you need to include the negative in parentheses with that letter. Okay. If I can draw a straight line. Okay, all divided by, or all over 2a, 2 times 4. So, simplify a little bit. X equals negative 3 plus or minus square root. 3 squared is 3 times 3 is 9. 4 times 4 times 9 is 16 times 9, which is 144. Negative times negative is positive, so this is plus 144. All over 2a, 2 times 4 is 8. One more time. X equals negative 3 plus or minus square root. 9 plus 144 is 153. All over 8. Now you can leave it like this, or you can come up with an approximate answer here. Let's go ahead and do the approximate answer using our calculator. So just like before, SQRT is square root. So negative 3 minus SQRT, 153. Hold down the shift and left arrow until the whole thing is selected. Put it over 8, divide 8. Okay, you can now copy Control C and Control V the whole thing and just type a plus instead of replace the minus with a plus. to get the other answer. So negative 1.92 or negative 1.92 or 1.17. If you were asked for an exact answer, I would leave it like this. If you were asked for an approximate answer, I would leave it like this. Okay, and that's it. That's the quadratic formula and completing the square. That's a lot of material.